about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to improve the display of the custom knobs that we are working on. So in case you're new here, we are doing a series of audio effects, real-time audio processors using the REAPER JSFX language. And we are doing a library that will help people do user interfaces and some basic algorithms for digital signal processing. And more specifically, right now we are working on knobs on the user interface. Let me show you what we have right now. We did this last week. It is a simple circle, a simple line, and when you click and drag, it goes up and down, and when you double click, it resets. Super exciting, right? And today we are going to try and make this look a little better. The first thing I have in mind is that this line is too thin. And last week we played around with different ways of making this line a bit thicker, but none of them worked very well. Here are some of the ideas that don't work very well, and then the idea that I had over this weekend that we are going to try and implement today. First idea that does not work very well is to use native JSFX line thicknesses. It doesn't work very well because it doesn't exist. In JSFX, you cannot, with the basic drawing primitives, specify the thickness of a line. It's always a single pixel. So idea number 2 is to draw a bunch of lines one next to the other. And that sort of works, actually. We did this before, like 110 streams ago, we did something like that, and it sort of works, but it doesn't feel nice. It doesn't feel nice to do it, because you have to do a loop to do a bunch of line drawings. It may not perform as well as it could, so it doesn't feel okay. Then there is idea number 3. That we have also implemented, and we played around with this last week, and that is to draw a bunch of squares. So you find the path between one point and the other, and then you again do a loop, iterate over, well, each pixel I would like to say, but actually it's just a bunch of times. You iterate a bunch of times and you draw little squares. That doesn't look very good because of aliasing. When you start moving the line like this, it aligns with the pixels very well, but when it is like this, it does not align with the pixels very well, and this is performing some anti-aliasing. This, by the way, that you are looking at is too thin because it is using the native JSFX drawing primitive, which knows how to do anti-aliasing. What it does not know how to do is different thicknesses. So you end up trading off the thickness of the line for some aliasing that does not look good. So those are the 3 ideas that don't work. Let me now explain the idea that I think will work. And before I do that, let me say hello to Mage and Bo. It's great to see you here. And I have a question for both of you. How is the quality of the stream, the sound, the sync, the video, and everything? Syncing of audio and video is a lost cause. I'm probably sounding a bit off. It's always like that. But I'm asking you this because I recently updated OBS to version 28, and I had to reconfigure many things, learn new things, because it was a major update, not only in the sense that it was from 27 to 28, which is a major version, but it was a big change. So some things may be broken. I don't know. All right. So yeah, let me know if the quality of this stream is as usual. And let's get, oh, yeah, you have already answered nothing new or unusual. Great, that's great to hear. Well, the thing that is new, but you don't get to see, is first, the user interface on OBS 28 is so different. It looks so nice. And the second difference, and that's why I wanted to do this update, is this little guy here. It is amazing. Before the update, I was running OBS 27 that did not have support for macOS and for Apple Silicon, for the M1 processors. It was running under the Rosetta 2 emulation, which works great, but it was taking about 20 to 30% of my CPU. And with the native version, it is taking less than 10%. It is bananas, the difference that this makes. So far, I haven't noticed the difference in performance when using Rosetta in anything, but in OBS, it is massive. Perhaps that will translate to better quality on the stream, hopefully. Yeah, the video looks 200 milliseconds behind. Yeah, it's always like that. It's always like that. And the problem is that it's always different. The latency may change in the middle of a stream. It's a lost cause. I don't know what to do about it. I sync things to the best of my ability, and it always comes out of sync. I didn't do anything about the lighting though, so... But yeah, thanks for letting me know. Anyway, let's get into the idea I have for how to draw thicker lines. And it goes like this. So you want to draw a line between point A and point B. And as I said, in JSFX, you cannot specify the thickness of this line. It will always be a single pixel. But what I thought about doing is to use the GFX triangle primitive. And while it is called triangle, it really can draw any polygon. You give it a bunch of points, and it will draw and fill in the shape of between those points. Now that I say this out loud, is it going to fill in the shape, or is it going to just draw the contour? Because if it just draws the contour, then this idea is not going to fly. Yeah, we have to check that before we get into this idea. So if I draw from 0, 0 to 10, 10 to perhaps from 0, 0 to 10, 0 to 10, 10, and I will set as the color some bright red. Yes, it fills in that space. How does it do in terms of aliasing? Because that's another indication that it may not worth pursuing this idea at all, actually. But let's see how it does in terms of aliasing. Aliasing on the coordinates I gave are exactly 45 degrees, this line here, so it's not the best way to test aliasing. So let's put something else. First, let's make this bigger. And then let's make this last coordinate on the y-axis, let's give it a strange number, like this. So how does it do in terms of aliasing? Bad. It does not do good. Crap. Perhaps there is some kind of setting I can use. Crap. No anti-aliasing inside. Oh well. Let's go and try this anyway, because it may be a good exercise and perhaps it will look good. I don't know. We'll see. So the idea I have is that we will find, so suppose that this line, we want it to be like 5 pixels thick. So what we do is we find this point that is 2.5 pixels away from this big point. Let's make the drawing bigger. So it's 2.5 pixels away. Let's say that this is 2.5 pixels away from this point, and this is a right angle. Similarly, we find another point still on the same line that is 2.5 pixels away from the given point. So this distance is also 2.5 pixels, just like that. And then we find the equivalent points for the other end of the line, like this, where these distances are also 2.5. And then, so we will be writing a function that given these 2 points and a specified thickness, it will find these 4 points and then call JSFX triangle with them, with the 4 points. So it will draw a rectangle that spans across these 4 points. And what is a thick line if not a rectangle, right? And I guess this is going to be our first attempt, and we'll see if this works well. And if it does work well, then as a bonus feature, we could have a line cap that is not just a square or a rectangle. We could have a line cap that is rounded by drawing a circle at the end. So the circle would have the center right at this point. My drawing doesn't reflect that all that well, but the center would be right on that point, and the radius would be this distance, in this case 2.5 pixels. And then we would get rounded line caps, which I always prefer. I tend to prefer rounded line caps like this. So that's the idea. Is it going to work well? I don't think so. Now that I saw that aliasing, I don't think it's going to work all that well. But we'll try it anyway, because I think it will be fun to find out a way of computing these coordinates. Yeah, how do we even do this? Well, I guess I would start by computing what is the angle of the line. And we know how to compute this angle because we have looked at imaginary numbers, the so-called complex numbers, and we have seen how to translate them from x, y coordinates. So here are the x and y axis. So we learned how to transform a point from the x-y coordinate system into a polar system where you have a magnitude and a phase. And in that case, we would be calling that a phase, but in our case, we would be calling this an angle. So the 2 points that we are given don't necessarily sit on the origin. So I guess what we'll do is to first translate this whole system so that I could probably just look it up on the internet. Probably there is already some Wikipedia article, some algorithm, some page somewhere that just hands me the solution for the problem. But I'm going to try to figure out a solution from first principles. So what was supposed to be, let's draw some cute knobs, becomes, let's do some geometry, because why not? That sounds like fun. So the first thing I want to do is to take these 2 points, and I guess I'm going to give them names. This is going to be P1 for point 1, and this is going to be P2 for point 2. And I probably want to know this angle, which is the angle between points 1 and 2. Not the other way around. I probably want to know what this angle is. So the plan is I will figure out this angle so that I can compute this angle. And then I will have another case where I have some magnitude and phase, and I would want to translate this into an XY coordinate or a so-called rectangular form. Because then I will have this angle, and I know that the magnitude is 2.5. Yeah. Probably there are ways to optimize this even further without having to find this angle first, and probably we can leverage the fact that this is a 90-degree angle to figure this out faster. Yeah. Yeah, if you already know how to do this, then yeah, let me know in the chat. Okay, let's start with this translation of the whole system so that it sits on top of the origin. And I think that what I will want to do is to put P1 at the origin. So I will want to take this origin of the whole Cartesian system and translate this whole thing so that it is right here. And the way that I can do that is by subtracting these 2 points, because P1 minus P1 will be 0, which is the origin of the Cartesian plane. And P2 minus P1 will be this, not to scale in this case. Like this. I think that that's the right way to do this. So let's start with this. Let's start by implementing this, and we'll also implement a skeleton of what the function should even look like. I will have P1 X be 100, P1 Y 100, P2 X 250, P2 Y. Well, that's a case where we have to stop and think about things. We are on this Cartesian system here. We're thinking mathematically, so our x's increase to the right and our y's increase going up. But in JSFX, we know that it's actually not like that. In JSFX, x goes increasing to the right, but y increases when it goes down. So if I want to have a situation like this on the page, where P1 is to the top and the left of P2, then my P2y needs to be not smaller than, but greater than P1y, so that it is below. So in our code, let's have, instead of, well, I guess we can have 250. It is larger than 100. And the cool thing about these coordinates is that we know that this will be a 45 degree or 45 plus 90. We'll see, but it will be a round value. Yeah, I think that this will do us good. Then, let's see. P1 at the origin, it's kind of silly for me to compute this because I said that P1 at the origin is P1 minus P1, which we know to be 0. And the same for y. So that's a bit silly. But let's do P2 at the origin. That's a bit less silly. So those are the coordinates of P2 when translated to the origin. And I will put as comments here as we are exploring this, the results I get. So this is what I wanted to get, and that's right. But what is this minus that? It's 150, and that will be 150 as well. Okay, so far so good. That matches our expectations because this value is supposed to be smaller than this, and it is supposed to be down here. And remember, our y's are positive below this axis. They're positive going down. Okay, so far so good. Now let's find this angle, which is the angle between P1 and P2. And I think that what we need is this. That sounds about right. That is the implementation from our imaginary numbers. Well, not really. This is not correct because I am not treating the x and y coordinates. So what's going on here? Well, this angle between P1 and P2 is actually in terms of these two coordinates. So I need to give this here and that there. And I expect this number to be, first of all, in radians. So let's check what is the radians or degrees to radians. The other way around, radians to degrees of that. And I expect this number to be something like 45. Yeah, let's see. Dale is here. Hello. The x offsets from P0 and P1 are the same magnitude, just plus VE and minus VE. Same for the y offsets. Just need 2 trigonometric calculations. So it seems like you know the answer to this, but let me show to people what I am reading. So Mage is giving me the answer, but unfortunately I'm not smart enough to understand the answer. I think I understand what you are saying. And if I do, I think that what you're saying is that this distance, which is the x offset, is the same as this distance, which is the same as this distance, which would be the same as that distance. And the same for the y coordinate, for the y-axis. So this distance would be the same as that one, which would be the same as this one, and the same as that one. So I only need to compute this offset and that offset, and I will be good to go. And probably there is a shortcut for me to compute these things, right? Yeah, I will continue with the way I was thinking, and we'll see if we get to the same answer. But I see what you mean. And yeah, I know there is a better way or a shorter way to do this, but I thought it would be fun to work on this from first principles. You know me, I like these kinds of things. So now we need to load this plugin and then confirm that we are getting the values we expect to get. This is kind of trivial, but I will check it anyway. These are zeros and these are 150s. Sometimes it's useful to check even the trivial things because maybe you made a typo or something. Then this angle, this will not tell me much. It will just be a value. But if I convert it to degrees, we get 45. So far, so good. We are on the right track. So now I know these angles, or I know actually this angle. Next, I want to know, let's say, this angle. Well, this angle, I know it is 90 by definition, because these two lines are perpendicular. This drawing is getting busy, and it will only get busier as we proceed. But anyway, so we know for a fact that the angle between these two lines is 90. And now we know that this angle is 45. So the next thing I'm interested in is this angle here in green. Because if I have that angle in green, I know how to compute this point. So let's try to figure out how to know this angle in green. Well, we know that the angle in yellow is 90, and we have just computed this new angle. So 90 minus the new angle is going to give us the green angle. Let's write that down. So 90 minus this. Well, not 90, because this is in radians, so it's pi over 2. Pi over 2 minus that angle will give us the angle. I guess it's time for us to start naming these points. I'm going to call this point P1 something, and I will call that point P1 something. And these are going to be P2 something. Guess this will be P1A and P1B, and P2A and P2B. So then we get this line that I'm going to call the B line, and this line that I'm going to call the A line. All right, so now we know the angle of P1A. That's the computation we have just put on the screen. So P1A angle is that. And let's see what it actually is. Well, in degrees if we can. It's 45. Sure, because 90 minus 45 is 45. And that makes sense here on the page. Well, does it? No, It does not. I don't want these two angles to be the same, because then I would be putting my P1A on top of P1. Or I guess on top of the line between P1 and P2. That's not correct. So coming back here to the drawing, if the angle, this inside angle here, let's put a color on that little angle, get the drawing even easier. So we computed this, I want to say red. Is this red? Do you think that this is red? I think it's red. So if the red angle is 45, then the green angle should be something like minus 45. Well, that's easy in the code. If we want to make that happen, we just need to inverse the order of the parameters. Because 45 minus 90 will be minus 45. And there you go. That's looking good. And I guess, again, because our y increases when going down, it also means that our trigonometric circle goes in the clockwise direction instead of counterclockwise. Isn't that amazing? Amazingly confusing. But okay, we got it. This is the P1A angle. Now, let's compute P1A. And this is actually at the origin. All of this is at the origin. So I'm coming back to Visual Studio Code because I can rename things faster here. So this is P1A angle. Oh, I don't need to rename anything because this is just the angle. But now let's compute P1A origin x, because we are still in that translated situation. We are still translating the whole thing to the origin. So what is P1A origin x? That is, I will need the magnitude. Oh yeah, so let's have another parameter here, which is like the thickness. And in this case, let's make it thick. So I guess 10, maybe like 20. So we want half of the thickness, because half of the thickness will go to one side of the line and the other half to the other side of the line, so that the line is centered around the coordinates you gave me. So that's the magnitude. And let's take a peek at how we converted from polar to rectangular coordinates. This is something we saw last week as well, but this is the formula. So on the x-axis, we are going to take the magnitude and multiply by the cosine of the angle. That's that. And for the y, this is very similar, except that we take the sine instead of the cosine. And at this point, I think we can leverage that symmetry that Mage was bringing up to compute P1B. Because the whole thing is at the origin, we know that P1B is just the opposite of P1A. Right? Geometrically, that makes sense to me. So if this point is at the origin and we have just computed this point, we know that this one is the exact mirror of that one. Just like that. Now let's sanity check this thing. P1A is supposed to have an x coordinate that is positive because it goes to the right, and an y coordinate that is negative because it goes up. So the x coordinate, I expect this number to be positive, and it is. Great. And I expect this number to be negative, and it is. Awesome. And naturally, I expect the converse here. So this I expect to be negative, and I expect this one to be positive, which is quite trivial. Okay, so far so good. We made 2 of the 4 points. How about we check that we are going well so far and focus on taking the translation back from the origin back to the position of P1 so that we can draw something on the screen and take a look. But before we do that, Aviated Views Sound is saying, you're still trying to figure this out? Yes. Why? Do you know the answer already? Let me know. But I think I will finish this exercise and then we can compare the answers. But yeah, I'm still trying to figure this out. So if P1A origin x is this, then we just add P1x. Yeah, because we subtracted P1x before, so we add P1x now, and we get the coordinate of P1a translated back to where we want it. Just like that. And then we can do a bright red. And go from, oh, I forgot P1b. Let's do the same for P1b. And here in the middle, we'll put P2. What I am doing in this test is I am drawing a triangle between these 3 points. Like that. Let's see what happens. Hey, it's looking about right. Awesome. Really? Is this going to work? Are we going to be able to figure this out even first try? That's amazing. It never happens to us. Let's try P2A and B now. P2A and P2B. Well, if we leverage that symmetry that we leveraged here, for instance, then P2A and B are not that difficult to compute, I think. We will have something like P2A at the origin x. Yeah, no, in fact, think that there is a little trick we can play. Can this work? Does this make sense? I think it stands a chance of working. I think it resembles what we would want. I have a hunch. Hey, there you go. I'll explain my hunch now that it worked. I'll explain what I had in mind. I was actually just leveraging that symmetry that we talked about on paper, where we know that this distance is the same as this distance, and that distance is the same as that distance. Cool stuff. So I just took the results from P1 and translated them to P2, and that worked. So we have a solution that I think is working. We will play around with the values some more to see if we don't get any strange behavior, because we are putting ourselves in an easy situation by just dealing with 45-degree angles. And then we will try to simplify this further, because I think that, for instance, we don't necessarily need to have this origin thing. We'll see. I think that there are some ways to simplify this a little bit, because it feels a bit wasteful to do the subtractions and then additions, but perhaps they're unavoidable. Anyway, let's first play around with these numbers a little. And what I'm going to do is just play around with the numbers, and I expect this to be a thick line. I don't want it to become any sort of triangle or trapeze or anything like that. That's what we are looking for. By the way, let's see what people are saying. Yes, yes, we figured this out. And I think I understood what you meant with your message, right? Yes, Leandro understood something. That's amazing. Why am I on this camera? I should be on this camera. Have I been on the wrong camera for too long? I think I have been on the wrong camera for a while now. It happens when you're on your own director. Yeah, let's play around with these values some more. Yeah, it is aliasing like crazy, but it is always a rectangle. Let's have this as sliders. Why not? It will help us play around with this. Yeah, that's how you do it. I will commit what we have, and then I will start playing around with possible simplifications for this. Well, these are no longer true. And where are we using this? Oh, check this out. We are never using this variable. And I suppose we are never using this one. We are never using this one either. And this one we are using, but we are using it only there, and this one we are using only there. So let's replace. I know it's kind of simple, and perhaps that's what aviated views sound was alluding to, that it is so trivial, this sort of thing, but it's oddly satisfying to figure all this out from first principles just using pen and paper. Even if I could look it up on the internet. Oddly satisfying. I like it. I am having fun. It really makes your head hurt if you add a third dimension, z. True. Could be fun though. It could be one of those things that don't really serve a purpose, but are eye candy. For instance, on Psyche's plugins, he has... What is one that I remember being the lava reverb? I was like, it's so unnecessary to do all this graphics and everything. Doesn't make it sound any better, doesn't make it more usable, but it's so freaking cool. So yeah, we could do some 3D stuff. when you put this next to this, it really makes you wonder your life choices, doesn't it? I'm so happy that I was able to do this. Yeah. Now check this out. Well, we can only compare ourselves with ourselves from the past. Let's continue with this. Is there anything else that stands out? Well, these we can get rid of. They were just scaffolding while we were playing around with the values. Did we break something in the process? Yeah, no, not yet. What happens if they are on top of one another? Does it behave well? It glitches out a little. So now you know. Remember to not ask this function to draw a line that doesn't have any length. We're probably like dividing by 0 or something at that point. Whatever. Don't do that. Any non-obvious simplification? Well, we do need to do this because we need to compute some kind of angle. And we do need that because we need to inform the problem that we are interested in a line that is at a 45-degree angle. So I think that this is sort of we can always inline stuff, but fundamentally we cannot simplify these parts, I don't think. We also need this. It is an important thing. It is the thickness of the line. So this is strictly necessary. And I think that so is this. Because you need to know how far the points are from the given points, P1 and P2. So I think that these are strictly necessary. Then this I don't see how to simplify this any further, actually. Because we will need to compute 4 points, P1A and B and P2A and B. And then we are computing the X and Y coordinates of these 4 points, which ends up being 8 lines. So perhaps the variable names need to be improved, but and maybe we don't need to give these 2 points names. So yeah, there is something to be said about the naming convention, because unless you have watched this stream and you have seen me drawing P's and P1A's and so on, it would be complicated to read this kind of code. So perhaps the variable names could be better, but I don't think that we can fundamentally simplify this any further without any new insight into the problem. I don't think we are doing anything extra silly. And in this case, I did inline some stuff, but I think it makes sense in this context. Yeah, I'm happy to start extracting this into a function. I like to use someone else's math. I do that often. It's only when I'm faced with a problem that I think is just the right point in the simplicity versus interesting kind of thing. Like, I don't want it to be trivial. I don't want it to be super complicated. If it's in the right sweet spot, I like working things from first principles. I seem to recall someone doing ray tracing in JSFX. I don't know anyone doing that, but I am interested in knowing. Right, so let's take a moment to extract this into a function in the library, and then we will use that function instead of that function. And we'll see if this whole thing was worth it, if it will look any good. Right, so instead of, let's commit the current state of things, which we know to be working. And let's go into perhaps near the Bezier stuff that we have going on. Line or thick lines. I think I'm going to rename from thickness to stroke width, because that's the name we have been using elsewhere. And I think I'm going to rename from P1X into, oh, you know what? I'm not going to do a lot of renamings right now. I'm going to first extract the function, and then I will do the renamings all here in one place. It looks like a piece of garbage. That's what it looks like. It looks terrible. Well, it works, so let's pat ourselves on the back. But it looks bad. It really does. Because of aliasing and all the half pixels that would be going on here, anti-aliasing is just not happening. So check this out. It's so bad. It really is terrible. I mean, even at this angle that it was supposed to be good, it is so bad. What is this pixel doing here? Why is this here? What the hell? There are 2 wrong pixels now. I'm probably computing things like 0.1 pixel kind of thing. And then for whatever reason, JSFX just craps out and does something like this. It looks like a pile of poo. But let's power through, because I think that maybe if we do the round caps, that may improve things. We'll see. So we extracted a function. Let's commit that, and let's go to do some renamings, make it look a little bit better. Oh, so there is a precedent. When we were working with Bezier curves, those ones I did not derive from scratch. I used the Wikipedia article and I referred to some videos of other people explaining these things. But I guess at least we can follow the same naming convention from the Wikipedia articles about Bezier curves. So P1 becomes P0. Forgot a comma here, and you may be wondering, how did that work? Well, commas are not strictly necessary in the list of parameters. Isn't that crazy? I find that crazy. Then P2 becomes P1. And let's also take the color here as a parameter. Is that a color? I think it is a color. It is a color. Alrighty. Did I break something? I did not break anything. Great. This color is perhaps a bit too faint. Let's give it like a 700. I think that that will look better. Yeah, whatever. And now this whole origin thing, I'm not so sure about. We could be calling this like offset, X offset kind of thing. I don't know. Let's declare local variables for good measure. And did I break something? I did not. And let's put the circles there just to see if it makes it look any better. I want the origin of the circle to be P0. So this. I want the radius of the circle to be this. So I guess I will have another variable for this. Heck, no, I won't. And then another one at P1. Somehow it looks even worse. Why is it not? Oh, because it's not filled in. It's not filled in. That's why it's not filled in. So it's not circle that I want, and it's not OBS that I want. It is... Oh, I just want to have another option here, another parameter that is true, because I want to fill this in. And it really shows off the aliasing, because it doesn't even look, when the line is here, it doesn't even look like this circle is at the end of the line. It looks a little bit below the end of the line. And when I go up, then it falls into place. Whoops. And then here, it's so off. It's so off. It's a lot off. And then it falls into place again. And then it is off for a while. And then it falls into place when it's exactly at 45 degrees again. Oh well. I think that I would like this a little thinner. So if I make it thinner, does it look better? And probably red is not my color. I would probably want... let's look into the volume. Yeah, this one, to see what kind of gray we are using. We are using gray warm. And I want this to be relatively dark. If I want it to be dark, I need a bigger number, not a smaller number. No. No. Oh, well, we tried. We did some trigonometry. It was fun. But that's not how we are going to do our knobs. Let's commit what we have, and perhaps tomorrow we will be back again. And then I guess we will implement the idea of drawing a bunch of lines one next to the other, because when drawing lines, we have access to anti-aliasing, and that, I think, will make thicker lines look better. So, yeah, and it seems like Mage is agreeing with me. It does work well, though. Do you mean it does not work well? Because I don't think it's... Oh, ray tracing works well. I don't know. Or replace the triangle function with a few JSFX line calls. I think that's what we're doing tomorrow. More as the line gets thicker, say the option for 1, 3, and 5. Yeah, I remember doing that and it worked. What I don't remember is if we did any kind of angles on the lines. I think we may have done only horizontal and vertical lines. Anti-aliasing of a thick line, I don't think is the same as anti-aliasing a bunch of lines. So I know that this idea of stacking lines kind of works if you do horizontal and vertical lines, because then you're falling into the pixels just perfectly. But with lines at an angle, I don't think it will look good, because the line in the middle will be kind of like, say that the line is white and you're drawing on a black canvas. The line in the middle, it will be sort of gray, and I don't think that stacking up these grays is going to be the right thing to do, because I think it should only be gray at the edges, and then in the middle it should be, well, I guess perfectly white or perfectly black. So I don't think that that will work either. I think we would just have to settle with thin lines, or we'll have to settle with, perhaps we could have something like steps. We could quantize the steps. We could find steps that look good and quantize them. Or we could do a freaking image, like we learned how to do last week. We'll see. Aliasing, yeah, anti-aliasing will be applied to the JSFX line, and we'll try that tomorrow. In lies, a polygon uses integer coordinates, but circle uses floats. So maybe that's why it's not aligned consistently. Oh, good to know. No, I meant your code works fine, but you won't be able to use it, which is sad. Yeah, I don't know. I will keep it around in the library. Someday it may be useful. If you're drawing a static line, then you can find one that works well and leave it at that. Can we implement SVG drawing into a Reaper, or does it only support PNG encoded knob? Yeah, as far as I understand, JSFX only supports PNGs. You can only bleach PNGs. It does not know how to render an SVG. But you are asking if we can implement SVG drawing into Reaper, and yes, we can take the SVG and interpret the SVG in JSFX and come up with a drawing engine in JSFX that knows how to render an SVG. It won't be native, it won't be fast, and it will probably look like crap as we learned today. But it is possible. And for the simplest SVGs with a single path with just coordinates, which is the kind of SVG that you find, for instance, if you go to an icon library, something like this. It is just a path with a bunch of coordinates. And these are just Bezier curves. So when I was implementing Bezier curves, I thought about doing this, and we may get to it at some point for fun, because it is just interpreting this line and converting this into a bunch of calls to the Bezier drawing functions. So it is possible to do this for very simple SVGs, and of course, the more complicated you go, the more complicated it becomes, and it's not worth it. Might as well just use a PNG, but it is in principle possible, and I think that it would be fun to entertain this possibility. For the time being, thank you Aviated View Sounds, Tail, Mage, and Bo for joining me here on the chat. I'm looking forward to seeing you again tomorrow for some more line drawing. I was expecting to get to the knob decoration, and we spent the whole time in the drawing of a line, and we will spend even more time tomorrow doing that. And then on Wednesday, we will meet for the digital signal processing and C++ and Juice study group. So tune in on Wednesday for that. And that's it from me today. Thank you very much for watching. I see you again tomorrow. Bye. Have a good one. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.